Good morning, kids. In today's class, we are going to discuss about the projectile motion. In that, first we'll start with a basic topic called as basics of two-dimensional motion. So let's assume the let me choose that this be the y-axis. Let this be the x-axis. So here, let it be x-axis, and let this be y-axis. Here, I am going to choose a particle. There's a particle or ball or a stone, anything it can be. So let it be initial velocity. I'll give 3 meters per second. Let it have an acceleration AY equal to 2 meters per second square. How much acceleration? 2 meter per second square. So at t equals 0, let the particle be at origin. How do this particle is going to move? This is what we'll be studying. How do this particle will move under action of this initial velocity and acceleration? This particular background is there. Only acceleration we know, only velocity we know. If acceleration or velocity are in same direction, we know. No, but how they are perpendicular. How the particle is going to move, that will be studying. So the path of the particle will be is going to describe a parabolic path. It's going to describe a parabolic path. It's going to describe a parabola. After some time, the particle will be somewhere here. But how do you can say it will be there only after some time? Now, if you look at the because of initial velocity and acceleration, because of acceleration, the velocity along y-axis should keep on increasing, and there is no acceleration along x-axis. There is no acceleration along x-axis. So here, the velocity of particle will increase. In which direction will increase? Along y-axis, it will increase. Then after some time, let it be here. Let this be the y displacement. Let this be x displacement. Okay, these velocities I'll indicate here. This will have vx, this will have vy, and the velocity of particle, let it be v. Then this is at what time? At time t. At t equals 0, the particle was here. After some time t, the particle will be here. So now we'll write down the equation. So what is the along x-axis? X equal to ux into t. Along y-axis, it should be equal to a1 t square by 2. Let me substitute the value of t here. Initial velocity of particle along y-axis, let's assume to be 0. So can we write equations of motion along y-axis? Then what is this? Equations of motion along x-axis as uniform velocity motion. So the distance cost should be equal to speed into time. So let me substitute this equation. Y is equal to ay by 2. Okay, this will become x by ux whole square. Then this should be equal to ay x square by 2ux whole square. Look at how y is proportional to x square. So definitely how the particle is going to move in a parabolic path. So what is the path of the particle? It should be a parabolic path. How the path of particle will be a parabolic path. Okay, this is our primary equation. So this will tell us that this equation represents a parabola. So parabolic path. Then how to calculate the velocity of particle at any time? So velocity of particle should be equal to ux plus ax into t. So what is the value of ux now? Ux is, we assume it to be 3. This is 0 into time. 3 meters per second. What is Vy? Vy equal to Uy plus Ay into t. What is Uy? 0. Ay is how much? 2t. So can we calculate the speed of particle at any time t? Yes, we can calculate the speed of particle at any time t. So how much it is equal to? V is equal to Vx square plus Vy square. Vx square is how much? 3 square. Vy square is how much? 2t whole square. Like this, we'll get the speed of particle. Then it is going to describe a position vector is what I'll represent. I'll call position vector. What is this? This will be called as a position vector. So how to get the position vector? The position vector we can obtain r bar equal to xi cap minus yj cap. What is x is equal to ux into t? What is y? Y from here. Now, what is the value of y? Y will be ay t square by 2. Now substitute this value. This should be equal to ux is how much we assumed it 3t. Ay is 2t square by 2. So 3t minus t square. This is I cap j cap. I cap j cap. Okay, like this we can write this in the vector form. 3t I cap minus t square j cap. Okay, this is a what is this? This is a position vector. This is a parabolic path. This will be the speed of projectile at any time t. So all the quantities is what we are able to predict using this one. So this will give the position vector. And how the path, the projectile will move in a parabolic path. I think that's quite natural. No, you throw any stone, any ball, how it will move? Because of weight and velocity, it will deviate away from the velocity vector. Like this, we are able to predict the position vector, the path equation, and the speed of the particle at any time t. And if you look at this, this will make some angle theta. Can we calculate this theta? So this tan theta is equal to how much? Vy by Vx. What is Vy is equal to? Ay into t. What is Vx equal to Ux? So what is Ay? Ay equal to 2t by 3. With the time, what will be the tan theta? Yes, definitely it will also vary. It will also vary. So like this, if the particle moving in a plane, so we are able to express. So now where how it is moving? It is not moving along nor along x nor along y. It is moving in a plane. No? That's why we are calling this as two-dimensional motion. So it will, instead of moving like this horizontally, the particle will deviate away from the path here. So there's one basic idea what we should have. So let's analyze further. Now, if the particle there's a particle I had chosen. If it is having velocity like this, uy, and if you give initial acceleration along this direction, how it will deviate? It will start moving like this. This will be the path. Because of the acceleration and velocity, this will be the path of the particle. Okay, now similarly, if the particle is having velocity like this, and if acceleration is in this direction, how the particle will deviate in this direction. This will be the path. So what is this? This is called as a path. Similarly, if the particle, if it is having velocity like this, and if acceleration, some direction like this, how it should move? So it's going to deviate this direction. A very general idea is what you should develop first. Then if particle is having velocity like this, it can have velocity in any direction, and let there be acceleration in this direction. Then how the particle will move? The particle will deviate in this direction. It will be a parabolic path and it will deviate. Sir, is it possible? Why you are taking acceleration in one specific direction? Why not some arbitrary direction? Okay, we'll do one thing. If this is a velocity, look at the acceleration, some arbitrary direction, then how the particle will deviate. it will deflect away from its velocity vector. It will deflect away from this velocity vector. So all this, the particle, when you subject it to velocity and acceleration, the resultant path will be a curved path. The resultant path will be a curved path. How to decide what is the specific path? By mathematical equations. Okay, there's one basic idea of the like a particle moving in two-dimensional motion. If the particle is subjected to both velocity and acceleration, okay, so then how you do this? Okay, fine. Now which velocity is greater? If I assume that ux greater than uy, how the resultant velocity will be? The resultant velocity of particle should be somewhere like this. And the resultant acceleration will be, let's assume that ay greater than ax. The resultant acceleration will be somewhere like this. Then how the particle? The particle will deviate. Okay, it's not that velocity like this. So a particle what will happen, can have acceleration in either of directions. In any direction, it can have velocity. The resultant path should be decided by the net velocity and acceleration. The resultant of the initial velocity and acceleration will determine how it's going to deviate. So first of all, what we should have a basic idea how the particle will move. It should deviate away from the velocity vector. Okay, so this is the a very general idea. So the things which will be widely using, suppose say here, let me give one more example. If I give velocity like this, and if there is an acceleration exactly opposite what will happen, there's a possibility, no? Then it will not be two-dimensional. Then what is the path of the particle? It will move, it will undergo retardation. It will undergo retardation and it will return back and will move like this. This will be the path of the particle. So when it will be two-dimensional, only if the velocity and acceleration are in different directions, then only the particle will go for two-dimensional. Then only the particle will go for two-dimensional motion. Already, I think you have come across if I give velocity and if there is a retardation like this, initially retardation, how the path of particle vertically projected, it will ascend, then descend. So when it will be two-dimensional, only when if the velocity vector and acceleration vector, if there is some angle, then it will be a two-dimensional motion. Okay, agreed. There's one a gross idea a student must have, and in all the things, if acceleration is constant, if this if a is constant, then we can take help of equations of motion to solve the problems. Okay, fine. So this is about the basic condition one must know before going for projectile motion. Okay, thank you all of you. So we'll continue tomorrow. I'll come with another new problem, new conditions. Thank you all of you.